Welcome, everyone. I'm glad you're here today. We're about to dive into the fascinating topic of hydropneumatics tank volume calculation. On this first slide, I just want to warmly welcome you and introduce the subject. Over the course of this presentation, we'll explore how to calculate the volume of hydropneumatic tanks, understand their importance, and look at some practical methods. So let's get started and make this an engaging and informative session. Welcome to this video. Today, we'll learn how to calculate the size of a hydropneumatic tank for water pressure booster systems. I'll walk you through the process with easy step-by-step explanations so you can understand it clearly. This is an important skill because choosing the right tank size ensures your system operates efficiently and reliably. As we go along, I'll highlight the key concepts you need to remember, like tank volume and pressure calculations. Our overall goal is to make this calculation simple and straightforward, helping you to make better decisions for your water pressure systems. So, let's get started and make this process easy to understand. In this educational video, we're exploring hydropneumatics tanks. These tanks are crucial components in water pressure booster systems. They help maintain a stable pressure, which is essential for consistent water delivery. Additionally, they protect the pumps from frequent starts and stops, which can cause wear and tear over time. Today, I'll guide you through a straightforward, step-by-step process to calculate the volume needed for a hydropneumatics tank. We'll focus on key system parameters such as the pump flow rate, pressure settings, and pump start limits. Understanding these factors is vital for sizing the tank correctly. Whether you're a student learning the basics or a practicing engineer looking to optimize a system, this explanation is designed to be simple and easy to follow. Proper sizing not only ensures efficient operation, but also extends the lifespan of your pumps. So let's get started by identifying the essential parameters we need for our calculations, and I'll show you how they all come together to determine the right tank size for your system. Let's talk about the purpose and importance of hydropneumatic tanks. These tanks play a crucial role in preventing the pump from turning on and off too frequently, which can cause wear and tear. By doing this, they help maintain a more stable water pressure within the system. It's also important to emphasize that correct sizing of these tanks is key. When sized properly, they not only protect the pumps, but also help save energy by reducing unnecessary pump operation. So, in essence, hydropneumatic tanks help us keep the system running smoothly, extend the lifespan of our equipment, and improve overall efficiency. This ties directly into our goal of creating a reliable and energy-efficient water system. Now, let's talk about the key parameters needed to calculate the tank volume. First, we have the pump flow rate, which is measured in liters per minute. This tells us how much water the pump can move in a given time. Next, there's Zmax, the maximum number of pump starts allowed per hour. This helps us understand the operational limits and how frequently the pump can cycle on and off. Then we have PA, the pump start pressure, and PP, the pump stop pressure, both measured in bar on an absolute scale. These pressures determine when the pump kicks in and when it stops, maintaining system stability. Finally, there's PC, the tank precharge pressure, which is usually set slightly lower than the start pressure, typically about 0.2 bar lower, to ensure proper operation without unnecessary cycling. Overall, these parameters are essential because they directly influence how we size the tank and ensure the system operates efficiently and reliably within its design limits. Remember, understanding these key points helps us optimize system performance and prevent issues down the line. All right, now let's look at how to determine the useful water volume between pump starts. First, you take your pump's flow rate, which in our example is 300 liters per minute, and divide it by the maximum number of starts allowed per hour. Here, that maximum is 12 starts per hour. When you do the math, 300 liters per minute divided by 12 gives us 25 liters. This 25 liters represents the amount of water delivered between each pump operation. It's a crucial concept because understanding this helps us ensure our system operates efficiently and within the set limits. By calculating this, We're essentially finding out how much water is moved during the interval between pump starts, which is key for managing water supply and avoiding overworking the pump. So, keep this formula in mind. It's a simple yet powerful tool for optimizing your system's performance. Now, let's look at how we determine the total tank volume using this formula. First, you take your useful water volume, which in this case is 25 liters. Then, you multiply that by a pressure factor. This pressure factor is the difference between the stop pressure and the start pressure, divided by the difference between the start pressure and the precharge pressure. Essentially, it accounts for how much additional volume the tank needs to handle during pressure changes. In our example, this calculation comes out to 25 liters multiplied by 15, which equals 375 liters. This means the total tank volume we need is 375 liters. The key takeaway here is that by applying this formula, we ensure the tank has enough capacity to manage the pressure variations efficiently, supporting the overall system's performance and reliability. Let's take a closer look at this summary table. This table is really the core of our calculations. It shows all the steps we took and the values we used in our example. You can see that, based on these calculations, a 375-liter hydropneumatic tank is necessary for the settings we've chosen. Of course, it's important to remember that you should adjust these values based on your specific system's data. This ensures optimal performance and safety. Overall, this table ties together the entire calculation process and highlights the key factors we need to consider when designing or analyzing similar systems. When it comes to finalizing your tank selection, it's always best to use manufacturer charts as your primary reference. These charts are specifically designed to help you choose the right size based on precise data. Remember, you should also adjust the sizing to account for your system's elevation and the real-world conditions it will face. Factors like terrain and pressure variations can significantly impact performance, so taking these into account is crucial. It's also important to stay compliant with local codes and standards throughout this process. These regulations ensure safety and reliability, so always review them before making your final decision. For the most accurate results, I recommend checking with your tank suppliers for detailed sizing charts. They can provide insights tailored to your specific system layout and pressure conditions. Reviewing applicable standards before selecting the final tank size ensures you meet all safety and performance requirements, making your system both efficient and compliant. Thank you so much for being here today. I really appreciate your time and attention. If you found this presentation helpful, I encourage you to subscribe for more updates and content like this. It's a great way to stay connected and continue learning together. Remember, the key takeaways are about the importance of applying these concepts to make a real difference. So stay curious, stay engaged, and I look forward to connecting with you again. Thanks again, and have a wonderful day.